Hello, let's continue our advanced Sudoku series with Sandwiched by Jovial. So this is puzzle number 2 of chapter 3 of the Sudokult Gospel document, which you can find in the description. You can also find a direct link to this puzzle in the description. And as always, I know what technique I'm looking for and how it works, but I do not know where it is in this specific puzzle. So it is a quasi-live solve in that way. And of course, if you can try the puzzle yourself with the link in the description, and I'm going to get started right now. We just take a second to appreciate the symmetry of these givens. It looks really neat. It's like a star or something with rays coming out of it. Kind of neat. All right, I'm seeing 2 3s here looking in, and this 3 looks up, so we can place this 3. These 3s look into this box, putting a 3 in one of these 2. Anything else with 3s? These 2 3s look down. This 3 looks in. That places this 3. Those 3s look in, putting a 3 in one of these 2. Oops, one of these 2. The middle box has 3s here. Okay. Did I miss any boxes? Let's see. All right, yeah, so we have 3s have these cells left. Okay. All right, what else do we have going on here? 1, 2, yeah, there's 2 7s here, and this 7 looks up, so we can place this 7. These 2 7s look in, putting a 7 in one of these 2. 3 7s, 5, 6. Looking for anything else to do before moving on. 1s aren't good enough. This 5 and this 5 does put a 5 in one of these 2. All right, these 2 6s look down, this 6 looks in, putting a 6 here. These 2 6s look left, putting a 6 in one of these 2. All right, anything down here? 1, 3, 4, 5, 6, 8, 9. No repeats. Yeah, I'm not seeing anything specific. All right, how about down here? There are 4 digits left in this row. What are they? They are 1, 3, not 3, 1, 4, 5, and 7. So 5 is limited to these 2. Let's mark that green here. Actually, I got some advice that instead of corner marking the 5s, what I could do is I could use whatever 5 is on the keypad, which is purple in this case. We'll see how that goes, but it does mean that 5 is limited to these 2 cells in the row. Do we have more restrictions on 5s? 5 is in one of these 2 cells. What about in this box? Oh, and it's in one of these 2 in this box. So I don't think I need that because the box is already telling us that. Okay. 3s repeat down here. I'm not seeing any other repeats down here, am I? Oh, the 8 looks in? No. How about this 7 and this 7? Okay, so 7's in one of these 2. That points up along with this 7, putting a 7 in one of these 2. We're getting quite a few basics out of this. Is there anything interesting about 1s? Only because I suspect that, yeah, if anything's going to happen, it's going to be on 1s, but it could be any digit, really. Let's see, 1's over here. Okay. Oh, the 1 and the 5 actually form a hidden pair in here. So this is a 1-5 hidden pair. So this triple is going to be 2, 6, and 9. Ooh, okay. They clean up a little bit. What else can we do here? 9's in one of these 2. Okay, so how does 9... Is 9 limited in this box? No. Okay, 9's in one of these 2. So we'll use blue for that. Okay. 3s, no. Anything join? We got this hidden pair, which makes me think maybe there's a hidden pair here too. But I don't see it. This 8 looks in. That doesn't help me. Okay. 1. Are 9s at all restricted elsewhere? Not that I can see. So we had 5s here and 5s here. We have 5s here. Ones were... So in this row, 1 is here or here. Okay, so we'll use light gray for 1. Because light gray is in that slot. In the 1 slot. Ones are here. So in this row, 1s are in these 3. In this row, 1's in 2 places in this row. How about up here? So 1s are out of these cells. This one sees these. This one sees these. Yeah, so 1 is in this row here. 1's out of here, 1's out of here, and 1's out of here, and the 9 and 8 are there. So 1s are in one of these 2. And we have just found a swordfish on 1s. So let me explain the swordfish. There's a few ways to, obviously every technique has a few ways to understand it. So let's go over a few ways you might understand this. So let's just do the plonk method first. So first of all, let's talk about what we're looking for a swordfish. So the reason that I know this is a swordfish is in this case, in this row, and this row, we have highlighted in gray. In fact, I'm going to, instead of using gray, I'm going to use something a little bit more visible. I'm going to use green, but that is still on 1s. And I'm going to get rid of the blue so that it's not confusing. All right. So in this row, row 3, row 6, and row 8, green is the only place we can put a 1 within each of those rows, right? Because this one takes it out of these 3. This one takes it out of this one. The 7 and 6 aren't 1s, and this one takes it out of here. So that's that row. In this row, this one takes it out of these 3. This one takes it out of this one. 9 and 8 aren't 1, and this one takes it out of this one. In this row, 7, 6, and 3 aren't 1, obviously. This one looks down, this one looks down, this one sees both of these. So these are the only place in these rows that we can put 1s. Now, what we can do is we want to see those lining up. So because there are 3 total columns for the green cells, there's column 1, column 4, and column 9, and that matches the number of rows I used. So I used 3 rows, and they line up also in 3 columns. Now, they don't have to be limited in those 3 columns. In fact, you don't want them to be limited in those 3 columns. So, for example, this cell can be a 1, right? Nothing's stopping this cell from being a 1. Or is there another example? There might not actually be another example. This cell could be a 1, right? So in the columns, we aren't necessarily, we don't want them to necessarily be limited to just those rows, but we have 3 rows, and the green cells occupy 3, they overlap in 3 columns. Now it doesn't, just like you're finding like a triple in Sudoku, like if you're finding a triple, you can omit, like these cells are omitted, you can omit those just fine, right? You could, if you pretended that 1 could be in here, like now you'd have kind of a proper swordfish, quote unquote proper. You'd have a full swordfish at least, a one that used all of the possible cells you could use. But removing that doesn't change the logic. Removing a cell from a piece of logic cannot make the logic weaker, can only make the logic stronger. In this case, so it'll do the same eliminations, at least, as the version that has those in. So anyway, what we found here is it works kind of like a triple, where if you think about it, like this row is going to need a 1, this row is going to need a 1, and this row is going to need a 1. And kind of if you think about it, like how am I going to put a 1 anywhere else in these columns that doesn't completely break? Like it's kind of, if you think about like a naked triple, right? If I had, I don't know, where's some scratch space here? If I had yeah, ignore the red marks here. If I had 1, 2, 3, 1, 2, 3, and 1, 2, 3 here, that's a naked triple, right? Why does that eliminate 1, 2, and 3 from the rest of the row? Well, it's because if I were to try to put a 1 here, for example, then now all 3 of these would have to be 2, 3, right? If I were to try to put a 2 over here, all 3 of these would be 1, 3. And you can't fit 1 and 3, like you can't spread 2 digits across 3 cells. So let me just make sure I don't mess anything up by undoing. So it's the same thing here, where I'm going to put a 1 somewhere in here. I'm going to put a 1 somewhere in here, and I'm going to put a 1 somewhere in here. No matter how I do it. Like I could put the 1 here, I could put the 1 here, and I could put the 1 here. Or I could put the 1 here, and I could put it here and here. You know, there's a few options. But what I can't do is put a 1 here. Because if I were to put a 1 here, then now this row needs a 1, and it can't be here anymore. So it has to be here. And this row needs a 1. Can't put it here anymore. So now it's going to be here. And now where's this row going to get a 1 from? Can't put it here, can't put it here, and can't put it here. So even if this was a possibility with our full swordfish, I now have nowhere to put a 1 in this row. It's actually easier to see now with these gone, but it's the same logic. So this can't be a 1. So what we do is the eliminations we get are in these columns. We actually can't put a 1 anywhere except green. So we can't put a 1 here. And we can't put a 1 here. And, you know, we can't put a 1 here, 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 here. There's already couldn't have been ones. But, you know, it's true. We can't put a 1 in any of the non-green cells of our swordfish. Yeah. So these are the eliminations in yellow. Blue. Blue are the eliminations. That too. And yeah, there you go. And we're assuming that these are part of the swordfish of green, right? So this is our swordfish. Again, removing these as green doesn't change the swordfish eliminations, right? So 1 can't go in any of the blue cells. So that is a swordfish. Now let me get rid of the blue here. Let me get rid of these. The sort of more technical way to define fish, if you're interested in that, is we have what are called base sets and cover sets. So the base set in this case are going to be our rows. So we're going to take these 3 rows. Let's make that gray. Let's make it purple. Purple is our base set. Our base set, you're going to pick n houses as your base set. In this case, it's 3 rows. So n is 3. So we're going to pick 3 rows as our base set. You could actually, you know, pick this to be your base set, for example. You could pick 2 rows in a box. Or you could pick a row. Having them overlap can be a little bit strange, but you could do like 2 rows and a column. But for basic fish, you're always picking the same type of house all 3 times. In this case, and you're only picking rows and columns. You're not using boxes. Otherwise, they're called like mutant fish or other names for like Frankenfish or things like that, which expand on the idea of fishes. But in this case, this is a basic fish, which only uses rows and columns. So our base set, in this case, are the 3 rows where we have limited where 1 can go. And then what we're trying to do is everywhere we've got this green, right? We're trying to cover the green cells with 3 more houses. And we're not allowed to use the purple houses. We're not allowed to use these rows. And for a normal fish, or basic fish, I should say, if we used rows for the base set, we have to use columns for the cover set. And again, that's just convention if we're just talking about basic fish. So we pick 3 columns. In this case, we can pick these 3 columns. I'll make those blue. And those 3 columns can completely cover our green cells. There are no green cells left in the grid that are not covered by blue. And if we can do that with the same number of columns as we used rows in this case, so however many base sets we have, in this case we have 3 base sets, 3 rows, if we can cover all of the places for a digit, in this case all of our green, with 3 columns, then we now have a fish of some kind. So basically with 3 different houses, we can cover all of green. And when that happens, any cover set cell that is not green, any cover set cell that is not also in purple, right? That's not also in our base set. So any cover set cell that is not also in our base set, you can eliminate that digit from it. So we can eliminate 1 from all of these cells that I've highlighted. So if I actually make holes here, if I wanted to, I don't know if I want to make holes here, but I'll just remove purple or blue and purple from those. So purple is representing our base set, and blue is representing our cover set. anything that's still blue cannot be 1 because 1 is limited to where these green cells are. So the reason for that is because we need n instances of 1. In this case, n is 3. So we need 3 instances of 1 in our base set because our sets are always, our houses that we pick are always ones in which you need exactly 1 of every digit. And so we need exactly 3 ones in our base set. We need 3 of them. And we're able to cover these green cells with 3 different houses, with these 3 blue columns. And we cannot repeat ones in the columns either. And so 3 equals 3, right? We need 3 of them, and blue can only provide 3 of them. So blue must provide all 3 of its ones to the green cells, which means it cannot put ones anywhere else. And that's kind of the really basic logic. That's the fundamental logic that's happening here. And so hopefully that's a nice rigorous explanation of fish for you. I'm going to get rid of the blue. Sorry, I'm going to keep the blue for a second. I'm going to get rid of the purple. So any blue cell that could have been 1 now can't be. So I'm actually going to mark these as non-1. So this can't be 1 anymore, but it could be 2, 3. It can't be 2, 3, 4, 5. It could be 6. It can't be 7. We have 7s marked. Oh yeah, there's a 7 there. 8. Could it be 9? I think it could be. Oh, it can't be 9 because there's 9 in the box. So this is a naked single 6 now. That gives us this 9, this 2, and this 6. And now this cell also can't be 1. Now I'm going to get rid of all the blues that were like, we don't care that it's not 1 anymore. This one actually we do care it's not 1. Okay. These we don't care. Obviously that we don't care. And this we do care it can't be 1. So let's mark these up. So it can't be 1 anymore because of our fish. It can't be 2, 3. It could be 4. It can't be 5. It could be 6. Can't be 7, 8. Could be 9. Okay. So now we can remove the blue. This one, can't be 1 anymore. Can't be 2, 3. Could be 4. Can't be 5, 6. Could be 7. Can't be 8 or 9. All right. This one we don't care. This one's already couldn't be 1. This one can't be 1 anymore. Okay, these already couldn't be 1. So for this one, and I'm going to keep these greens around so we can show that they do end up with 3 1s in them in the solution. Okay, so this can't be 1 anymore because of the fish. It can't be 2. Could be 3. It can't be 4, 5, 6, 7, 8. Could be 9. Okay, so now that those are marked up, our fish is baked into our puzzle, so we don't have to remember it anymore. I got a bunch of digits. So what do we do for that? There's 2 9s looking into here. Oop, those 9s look into there. So 9's one of those 2. Trying to follow up on what we got here. The 2 6s look up. This 6 looks in. So 6 is placed in this box here. This can't be 6 anymore. That's nice. What else did we get? So we got this 6. So these 2 6s look in. This 6 looks up. We place this 6. We have 4 6s looking into the middle box, so we always can place it when there's 4 looking in. That's a 6. Our 6 is done. 6s are done. Okay, that's nice. I want to think about this column. We need a 1, 2, 3. We need 4 and 5. Okay. Not resolved. This column has 3 left. We need a 7, 8, 9. Top one's not 7. Oh, this one's not 8 or 9. Very nice. So that's the 7. Oh, sorry, that's a 7. And then this can't be 9 either. So that's 8, that's 9. Right, 9 in this column was placed. There's a triple left in this box. There's a pair left in this box. Let's do that first. No, it's a triple also. I don't know. I'm flipping. 4, 5, and 8 go here. So 8 can only go here. And then this is 4 or 5. And then this is 1. Okay, 5 in this column. Oh, no, sorry. There's a 5 down here too. So this box needs 1, 2, and 4. Okay. Oh, this isn't 7 anymore. We can place this 7. So 7s look into this box. There's a 7 one of these two. Oops. Meant to quarter mark that. This column has 3 left. We need a 2. I'm looking at 2s here. 2 places for 2. 8, 9. This can't be 8 or 9. So this is the 2. And then we're left with an 8, 9. Oh, this can't be 9. So this is the 8. And this is the 9. That's not a 9 anymore. This rose down to 4 digits. Let's take a look. We need a 1, 4, 5, and 8. I'm not super excited about that. Oh, wait, I should have been. Why? This sees 1, 5, and 8? Yeah, it sees 1, 5, and 8. Oh, okay. So that's a 4. Wow, how did I miss that? Okay, that's not 4, 5. That's not 1, 4. That's not a 7. We can place the 7 now. I feel like we're finishing up here. This row has 3 left, so we need a 2, 3, and 8. Oh, I see the 7 here. 8 in this box is placed. Let's do that. That's an 8. That's a 3. That's a 1. That's a 5. That's a 4. In this column, we do a 1. Yep. So that's our 1. That's 1. We get the 2 and the 4. We get the 5. That's not a 5. That's a 5. This is 7. We get the 8 here and the 5. This is a... almost a 2. That's a... almost a 4. Wait, did I mess up? I can't place 4 in this box. So when did that happen? Did I miss... Ooh. I placed an 8 where there's a hidden 4, 5 pair. Where did I mess up? Did I mess up penciling this row somehow? 1, 4, 5, 8. Okay, so if that's a 4, that's a 7. That's not 4, 5. That's not 1, 4. That's not 7. That's not 7. So I feel like this has to end up 5, because we need 4 and 5 in here. So let's try that. 5 and 4. This is 1 and 4. That's an 8. 2. Let's see if this breaks again. That's 5. That's 9. That's 7. I'm hoping the mistake I made was after this. This is a 1. This is what? 2 and 3? I mean, it hasn't broken yet, but it doesn't mean it's not broken. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is working out okay. I must have made some kind of weird mistake there. What do we need in this column? We need 1. Oh, we do need 1 in this column. Right, our greens, we need a 1. And then this row is going to need a 1 as well, and it can only go here. So that's 1, that's 3. This pair is 5 and 9. Okay, that's 9, that's 5. This is 2 and... oh, 2 is placed. 2 and 4, okay. That's 3 and 2. So far, okay. That's a 4. So 2 goes here, and then that's a 4. Okay, in this column, we need a 5. In this box, we do need a... yeah, we can finish these rows. So we need a 3, which goes there. We need a 8 and 9. So that's 8, that's 9. This is looking good. That's a 1. We need 2 and 9. That's 2, that's 9. All right. I'm unsure what mistake I made, but luckily I was able to recover. We had this 4, 5 looking in, which did force this hidden 4, 5. So I based it off of that. I must have penciled something wrong or placed a digit I shouldn't have. All right, cool. And as you can see in our green cells, we did end up with 3 1s, as was needed by logic. This is where they ended up. one of a few options that could have happened. All right, cool. Hopefully this lets you understand fish in general a little bit better. If you want a really awesome primer on fish, the Sudokult discussion episode I did with Philip Newman called Let's Go Fishing. I will link that in the description. I'll put it here. I'll put it up here so that it doesn't spoil anything in the description. So yeah, go ahead and click that video. Maybe I can even do one of those end screen things. So over there, there'll be an end screen button there to watch Let's Go Fishing, which we go over this in great detail on how fish and complex fish work. So hope you enjoy all that. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.